using the data to find the mean and the median. Now, by mean, we mean adding all of the numbers up and dividing by the quantity of numbers. We also often call this the average. Now, since we're looking for the median, we're looking for the mean, we want to add 20 plus 22 plus 26 plus 29 plus 31 plus 33 plus 37 plus 189. And I'm going to go ahead and emphasize this real quick here. I want you to show me on your paper what all of these add up to. 387. The reason why I want you to add all of these up and show me is because quite often students will mean to punch 26 on the calculator, but they'll punch 16. Or they will mean to punch 29, but they'll punch 2. Or they will mean to punch 189, but they will only punch 19. And so their sum ends up different. If their sum ends up different and they divide by the correct number of terms, but they get a different solution, it's all wrong if I can't see any work to know where they made the mistake. But if you show me the sum, and I can then see that you took that sum and there were 8 terms and you divided by 8, and you ended up getting 48.375. I now know that this is what you calculated to be your mean. If you accidentally took 353, because that's what you ended up getting when you added these up, and you divide by 8, and you get some value of 44.125, and you have absolutely no work, your answer of 44.125 is 100% wrong. If you have work shown and you get 44.125, I can at least see that you know the process of calculating the mean, which is the standard that I'm assessing. And I can see that you simply made a mistake on your calculator. I can deduct a point or two rather than counting the whole question wrong. That will benefit you. Now, median. A couple of things we want to remember about median. We want all of our numbers in numerical order. It often helps to write them all out in one long stream. So 20, 22, 26, 29, 31, 33, 37, 189. Now, since we're looking for the median, I do not want you boxing or circling the two numbers in the middle. I want you evenly splitting your data set so that you have an even quantity on one side and an even quantity on the other side of the bar. Now, what's going to happen is if your bar falls between two numbers, you're looking for the average of those two values. So we will now add 29 plus 31. And we will end up with 60, and we'll divide by 2. And so our median is 30. Notice that there's a bit of a difference between the median of 30 and the mean of 48.375. Which one better represents the bulk of our data? Well, the one that better represents the bulk of our data in this instance is 30. Because most of our numbers revolve or are fairly close to 30. We're going to talk about that again more in the coming days. Now, let's assume for just a minute that I knock this 189 off. And we end up with 20, 22, 26, 29, 31, 33, and 37 as our values. Well, now I need to find the number in the middle, or set of numbers in the middle, and I have 1, 2, 3, 4, 5, 6, 7. I have an odd set of numbers. So I know that there's going to be an exact middle to this one. Now, in the case of an exact middle, we're still going to run the line through, but I'm going to run it through top and bottom so that I can see this is the exact middle. I have an even quantity of numbers north of it. I have an even quantity of numbers south of it. In this case, my median would be 29. Measures of variation. The measures of variation that you will be required to understand are range and IQR. We are also going to explore mean absolute deviation, which you should have explored to some degree last year, but we're going to revisit it. Range. The range is the difference, meaning that I'm subtracting, between the greatest and the least data values. So, it's really nice when you get range questions and your data is already in numerical order, because I need my largest number minus my smallest number. So my range is 5. When your data is not in numerical order, you're going to want to list it out. So come through and find your smallest number, 56, 57, 58, 59, 60, 61, 62, 64, 67, 71. Now notice that I crossed each one of my numbers out as I was using it, and I did not completely black out, draw through my paper so heavily that I drew a line right through, or a hole right through my paper. If I do that, I can no longer see what that number is, and if I make any kind of mistake here and need to start all over, you're either going to be printing out a new worksheet or calling a friend to figure out what that number is there. No, it doesn't take that. All it takes is a very simple scratch through the line so that you can still see the numeric value but know that you accounted for it. The range is again my highest number minus my lowest number. And so we have a difference there of 15. The range would be 15. Before we talk about IQR, we need to remember something about the Q portion, the quartile. Quartiles are divided into data sets into 4 equal parts. Each quartile contains 1/4 of the values in the set. So we can think of it kind of like a dollar is 4 quarters. And so each quarter is 1/4 of a dollar. Now notice that I've illustrated the range, 9 minus 1. I've illustrated the IQR. Now how did I find the IQR? I first had to find the median, the number exactly in the middle of the data. From there, I was able to split up my lower bound data from my upper bound data and find the median of each. And the median or number in the middle of my upper data is 7. The median or the number in the middle of my lower bound is 3. Again, notice how we have the dotted lines going through the numbers. That's going to make it so that I can tell that that's the median without me thinking that it's not that there are other non-included values. All right, IQR takes the difference from the midpoints of my upper and the midpoint of my lower. Or another way we can say that, it takes our Q3 value and our Q1 value and finds the difference. Interquartile range is calculated by taking the Q3 value, the middle number in my upper set of data, and subtracting the Q1 value, the middle number in my lower set of data. The upper and lower quartiles are the medians of the upper half and lower half of a set of data, respectively. The range of the middle half of the data is the difference between the upper quartile and the lower quartile, in this case, 29 minus 18, which equals 11. So our interquartile range for this set of data is 11. So with the given set of data that we have, we want to find the upper, lower, and IQR. Now I'm going to tell you, you can certainly mark off numbers until you find the middle, which is a strategy that some people use. I generally prefer to count how many numbers I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 numbers. All right, since I have 17 numbers, if we're looking for the middle of something, we usually divide by 2. That is going to give me 8.5. Now notice, if I have 8 numbers and 8 numbers, that's 16. We have not quite made it to 17. But if I have one number that sits right in between 8 numbers and 8 numbers, then I now have 17. So that's just a quick, easy way for us to figure out where our middle is. The 8 numbers lower bound plus the 1 number will give us our exact middle. So 1, 2, 3, 4, 5, 6, 7, 8 plus the 1 in the middle. Well, now I'm going to have another 8 numbers on the upper bound and 8 numbers on the lower bound. And we can repeat the process. We already know that we have 8 numbers here, so 8 divided by 2 gives us 4. We're going to have sets of 4 values and a median. Sets of 4 values and a median. Notice I had a median here. It was not part of the upper or lower bound. I have a median here. It's not part of the upper and lower bound, but each value to the left or right of it is. And again here, each value to the left or right is part of the upper or lower bound. So we want to figure out what number sits right in between these two terms, 4 and 5. Well, that would be 4.5. What value sits between 1 and 1? Well, no number really sits between 1 and 1, but when you find the average, 1 plus 1 is 2, divided by 2 gives you 1. So the difference between 4.5 and 1 gives us an IQR of 3.5. That wasn't too bad. All right, let's look at the next set. Ooh, again, our numbers are not in numerical order. So we're going to have to put them in numerical order first. So let's do this again. 56, 57, 58, 59, 60, 61, 62, 64, 67, 71. Now, I can see very clearly from the chart here that I have 5 columns, 2 rows, so I have 10 data points. If I take 10 and we divide it by 2, that equals 5. So I should have a line that separates 5 terms from 5 terms. 1, 2, 3, 4, 5 with a line. 1, 2, 3, 4, 5. Now I want to know where the middle number is. Well, with a set of 5, finding the middle number is really easy. So it falls there, and the middle number falls here. So my upper quartile is going to be 64, my lower quartile 58. That has a difference of 6. That's IQR. IQR should be a relatively easy review from last year. Identifying the IQR for the given set of data. Again, this is just extra practice, so let's work through it together. Now would be a good time to pause the video so that you can try it. All right, welcome back. So hopefully you put your numbers in numerical order. So 65, 73 followed by 77, followed by 83, followed by 2 85s, followed by 90 and 90, followed by 99 and 2 100s, followed by a 101. So that's got all of our terms. I can see here I have 2, 4, 6, 8, 10, 12 terms. I should be able to split evenly 6 and 6. 1, 2, 3, 4, 5, 6 terms. So my value there, 1, 2, 3, 4, 5, 6. It does split evenly. So now I want to split my lower bound, everything left of the median. So I'm going to have 6 terms that splits by 3. So 3 and 3. Up here again, 3 and 3. And I want to find my upper quartile. 99 plus 100 divided by 2 gives me 99.5. Down here we have 77 plus 83 divided by 2 gives me 80. So we want to find the difference. 99.5 minus 80 gives me 19.5 for our IQR. Now, yes, it's going to get slightly more complicated as you get slightly larger data sets. You should notice from this particular data set that these have already been put in numerical order. So it's not as bad as it thinks, even as you think, even though you have larger numbers. So we just need to know how many states we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 states. Now, I went ahead and numbered them just because once I get to 18, I want to know half of 18, that's 9. So my median for this set of data is going to fall right between those two. So now 9 divided by 2 equals 4.5. So 4, 4, and 1 in the middle gives me 9. So I'm looking for the 4 plus 1 fifth term. That fifth term is right here. Again, down here, I'm looking for the fifth term. 1, 2, 3, 4, 5. That would be Colorado right here. So my upper quartile is 156. My low sorry, that's backwards. My upper quartile is 314. My lower quartile is 156. And that gives us a difference of 158. So it has an IQR of 158.